everyone, welcome to another Dynamics, Physics in the Flesh episode, Hanging Block Off a Pulley. This is a classic problem in physics, especially in dynamics. Usually numbers are given for the masses of the pulleys, accelerations are determined, tension, forces are determined. In this question, we're simply setting up the formulas that you will use in order to do these problems in the future. Okay, so the image below shows a block, mass MA, on a smooth horizontal surface, connected by a thin cord that passes over a pulley to a second block, MB, which hangs vertically. A. Draw a free body diagram for each block, showing the force of gravity on each, the force, tension exerted by the cord, and any normal force. B. Apply Newton's second law to find formulas for the acceleration of the system and for the tension in the cord. Ignore friction and the masses of the pulley and cord. So, first thing I'm going to do is actually draw in my positive directions. Okay, so here is the diagram that's given in the problem. My positive direction, well, for X it's going to be to the right because that's the direction it's going. And for any vertical direction, the only direction we have is downwards. So I'm going to let down be the other positive direction. Okay, so that's going to be my Y. Okay, now for part A, we need to draw a free body diagram for each block. So let's do that. Okay, so let's do block MA first. Notice how it's set up here on a smooth horizontal surface. Usually that implies that there's no friction. Okay, of course they tell you in the question explicitly that as well. Ignore friction and the masses of the pulley and the cord. Okay, so here we go. For mass MA, take a look. There's a string connected to it attached to MB. The weight of MB is going to add tension to this cord. So there's going to be a force of tension going to the right. Now, if you remember in the previous video that I did, if you have two objects connected by one string, or rather one string in the question, it's the same tension in that cord. Okay, so you've got tension. Now the block's got a weight. Okay, that's going to be FGA. And now the table pushes back up on the block, countering its weight. So that's going to be the normal force A, FNA. Okay, for block B is just hanging. It's not on any surface, so there's no normal force. Okay, block B is a little bit simpler. It has tension going up. Now it's the same magnitude tension force that you have for block A because it's the same string. And the only other force you have is its weight. You have FGB. Okay, so that solves part A. We've got our free body diagrams. Now for part B, we have to apply Newton's second law to find the acceleration of the system and the tension in the cord. Since we're not given numbers in this problem, what we need to do is simply create expressions for the tension and for the acceleration. Okay, now the setup of all these problems is very much the same. Okay, you see how you've got the same tension because it's the same cord? Both blocks are actually going to accelerate with the same acceleration. So what you end up with these problems is acceleration as an unknown and tension as an unknown. Two unknowns, and you can create two expressions because you have two blocks. Two Newton's second law expressions. So in mathematics, if you have two equations and two unknowns, you can solve for both of the unknowns. Okay, so let's do one at a time. Let's start with block A. Okay, so for part B. For block A, we're going to be dealing with the x direction, the horizontal direction. So we're going to say F net x for A is equal to MA times acceleration. Okay, now the net force in the x direction for block A is simply the tension force. There's no friction here, so that's the only one. So Ft equals mass of block A times acceleration. Again, I'm not giving acceleration a subscript because both blocks, since connected by the same string, undergo the same acceleration. Okay, so I can't go any further with this formula, so I'm now going to start with block B and start creating expressions for it. So F net Y, because notice block B is only moving in the vertical direction, F net Y for B is equal to mass of B times A. Now, in the Y direction, we've got force of gravity minus tension. Remember, we let down be the positive Y direction. So that's going to be FGB minus FT equals MB times A. Now I'm going to isolate for Ft here. Remember I said two equations and two unknowns, so I'm going to isolate for Ft here and then set these two equations equal to each other. Okay, so let me just scroll up here. Now Ft right now, if I bring FGB on the right, I'm going to end up with a negative here. So I'm actually going to bring Ft to the right. So I get FGB, which is also MBG, minus MBA equals Ft. Okay, now this is Ft, this is Ft. So what I'm going to do now is set these two equal to each other, because they're both equal to the force of tension. And if you set them equal, you're going to get MBG minus MBA equals MAA. Okay. Now, the reason I didn't take out the like term of MB here is because that would complicate A. It would put MB bracket G minus A. But A is one of the variables I'm trying to isolate for, so that would actually make it more complicated. You see in this new expression, I've got two A's. Now here's where I want to use A as a like term and isolate for it. So let's get all the expressions with A on the same side. So we'll do MBG equals MAA plus MBA. Okay, we're going to isolate the A here, take it out. MA plus MB equals MBG. Now to get A by itself, it's being multiplied by the sum of MA and MB. So divide both sides by MA plus MB. MA plus MB. So that cancels out on the right. Now simply rewriting this so A is on the left, you get A is equal to MBG over MA plus MB. So there is your expression for the acceleration. Okay, so we now have to create an expression for the tension. Okay, so remember, back to here, the tension force is MA times acceleration. So we're just going to use that. Okay, so force of tension, so bringing that here. Okay, so force of tension is equal to MA times A. A is MBG over MA plus MB. So writing that a little bit cleaner, we are going to get that the force of tension is equal to MA and B over MA plus MB times G. You can either write the G to the side or you can keep it in the numerator since it's all a product. And there you have it. You've got the tension, you've got the acceleration. There are your answers to part B. Again, recap. For these types of problems, you've got two blocks connected by the same string. Therefore, they will both have the same acceleration. They're both going to have the same tension. So you create two equations using Newton's second law. You have two unknowns. And by the laws of mathematics, you can solve for each unknown that way, simply by plugging one equation into the other. And there you have your answers. So that's it for this video, guys. I hope you enjoyed it. If you did, be sure to click that like button and subscribe to Physics in the Flesh so you never miss a video from me, which, by the way, I post every weekday at 12 noon. So be sure to be on my channel at that time to see the latest physics problems solved. Enjoy the rest of your day, guys, and I will catch you in the next problem-solving video.